Here is a dummy load jig I made to test Allegra A4960 based brushless motor controller. It consists of two motors. The main motor is driven by the controller as usual, and the slave motor, having its windings shorted together, provides resistance to the main motor. The motors are mounted on aluminum brackets connected with a flexible coupler and bolted to the base plate. This is my test setup. The green board is a motor controller. It drives the main motor, and here I have a current probe clamped to one of the windings. Arduino board provides PWM to control motor speed, and two 3S LiPos wired in parallel power the controller. Here you can see my instruments. The oscilloscope shows current in the winding. A current probe amplifier set to 5 amps per division feeds the scope input. The upper power supply provides 5 volts to the logic side of BLDC controller. The Arduino terminal outputs the BLDC controller status, and I can also increase or decrease motor speed from here. Let's play with the motor a little. I want to observe typical no-load behavior, so just remove the short from the slave motor. The motor now spins much faster. And this is the motor current, about 5 amps peak to peak. Let's give it a spin. This is about 50% duty cycle. And this is the current, 10 amps peak to peak. Going up to 18-20 amps when I am braking the motor with my finger. Let's compare it with the dummy load. Here we can see 30 amp at pretty low speed. Let's try to speed up that motor. That's the fastest it will go. The speed is limited by the LiPos and the power supply. Here is 50 amp current, and my probe is specified at 45 amps max, so what we see is likely clipped. Now check this out. I'm moving the probe from the main motor to one of the shorted windings on the slave. And here's what we see on the scope, 45 amp sine wave. We can generate electricity with the brushless. This is it for today. Thanks for watching.